Following on from the previous video, let's optimize our website's images further to make them load even faster. Using Image Optim, a free app on Mac, we can remove unnecessary data within images such as metadata, thumbnails, and unnecessary color profiles which aren't needed on the web. However, this app isn't available on Windows, and using it means we lose our raw, unoptimized images. Instead, let's automate this optimization using our existing Gulp build process. The first thing we need to do is create a new image directory in source to hold the unoptimized source images. In here, move all JPEG and SVG files from their current location in the root www directory. Leave the GIFs where they are, as we'll tackle these separately. Now, open Gulp file. If you're unfamiliar with Gulp, this file contains all of the JavaScript that creates the tasks which we then get Gulp, a task runner, to run for us. In the clean task here, you need to add references to JPEG and SVG formats to make sure that when a new build is run, these files are deleted. This way, old files from prior builds don't make their way to live. Next, let's create an empty task called Compress Images. We'll then reference this here to make sure it runs when we type gulp build in the command line. To optimize images in Gulp, we need a dependency called gulp imagemin. Install it via the command line like so. Then back in the Gulp file, let's import imagemin so our Compress Images task can access it. And now here's our task. The gulp source function grabs all the images in the source directory before passing them to imagemin, which optimizes them at 75% quality. Once complete, the optimized image files are exported to our existing image directory in the root, which is where our website's code will be looking for them. Now if we run gulp build, we'll see some extra feedback in the log telling us how many kilobytes imagemin has saved us. This looks promising. By default, a normal JPEG loads from top to bottom, line by line, like so. By changing a JPEG from this baseline setting to progressive scan, we can alter this behaviour so a low quality image loads straight away and then progressively gets better as more of it is downloaded. By using progressive JPEGs on our website, this is a good implementation of the early completion technique discussed back in the perceived performance video. By making the full images appear straight away, we are giving our users something to engage with, turning a passive wait into an active one. How do we convert our JPEGs to progressive scan? That's easy. Just tweak the config in our Gulp task like this. Sorted. Another way we can further optimize our images is by taking advantage of newer file formats which offer better levels of compression, like Google developed WebP. WebPs can be created from any existing bitmap file format, including JPEG. To do this, we need to install a new imagemin plugin which can handle the conversion for us and a renaming utility function so we can change file names. Next, let's create a new task called Create WebP and add it to the Gulp build task so it runs after our existing Compress Images task finishes. This way, we convert the compressed images rather than the source. And as for the task itself, here's the code. This grabs all compressed JPEGs from the root www directory, creates a new WebP version for each of them, and then uses the same file name but with a different extension before saving them to the same directory. Then we just need to amend the clean task to include WebPs, so old ones are deleted on a fresh build. And speaking of build, when run, we end up with this. WebP variants of every JPEG. Side by side, there's quite a bit of difference in file size between the two, which is all the better for web performance. You may be thinking, now we've got our newer WebP images, why keep the JPEG originals? The answer is because at the time of recording, not all browsers support WebPs. So for browsers like Chrome, we can serve the newer, faster loading WebP images, but for browsers like Safari, we need to serve the original JPEGs. Another is WebP images don't support progressive rendering, so will load like baseline JPEGs. This means for key viewport images like this carousel slide, you may want to save the original JPEG instead to prioritise perceived performance. Though it's important to test both, as the difference in the WebP's file size may offset any advantage a progressive JPEG brings to render speed. Here, even on 2G, the difference is negligible. All that's left is to write logic to check if the browser supports WebPs or not, and then serve the most appropriate image format. The quickest and easiest way to do this is via server-level config in our htaccess file, which can be found in the root www directory. Here, we'll add a new rewrite rule which does the following when a HTTP request for a JPEG is made. Check if the browser supports WebP images. If yes, check if a WebP version of the requested JPEG exists. If yes, serve the WebP in place of the JPEG. Otherwise, just serve the JPEG as normal. This way, if WebPs are supported by the browser, the WebP is served with the same file name as the JPEG, extension and all, meaning no further work is required to change the paths in the HTML. So if you were to load the website with the Network tab in DevTools open, you would see this in action. Even though the requested image has a JPEG extension in the file name, we can see it's still a WebP. Overall, in this quick comparison I've run, serving WebPs instead of JPEGs mean the browser loads 34% less image bytes. The last images we need to optimize are these animated GIFs, which feature on the blog post page. Animated GIFs can be huge in file size. These ones are no different. Let's convert them to video, which on the modern web are much more optimized with a much lower file size. How do we convert these GIFs to video? This can be done using FFmpeg, a command line interface for working with video. Its website lists lots of different ways to install it, so pick the one most suitable for you. Alternatively, for your convenience, I've also included the converted GIFs as an attachment for this video. Using FFmpeg, in the command line, run this command to convert the first GIF into an MP4 video. This gives you the same video but at a much smaller file size. Once you've done the rest, you should be left with this collection. Overall, there's a saving of around 95% in file size between the GIF and video formats, which will do wonders for overall page load times. Before we implement these videos into the website, there's one more step we can take. Alongside WebP, the modern image format, there's WebM, the modern video format. Convert each animated GIF to WebM using this command, replacing the file names as before. This gives you 3 video clips with 3 very different file sizes. As all modern browsers support at least the MP4 version, we can safely delete the GIFs. Goodbye. Now open the blog post HTML file in the source directory and find the image elements referencing the GIFs. Replace them with these video elements. For each video element, we've added autoplay, loop, muted, and play inline attributes. These make the video replicate the behaviour of the animated GIF. Within these, there's the source elements. By placing the WebM source first, if the browser doesn't support that format, then it falls back to the MP4. Looking back at the web page, you can hardly see the difference, but it'll definitely load faster. By how much though? Well, if I run a quick comparison on this blog post page, I can see that compared to before, overall load times have dropped significantly. This is because we're loading only a tiny fraction of the image bytes we were before, having converted them to video, which itself only represents a tiny amount of bytes in comparison. I wasn't expecting huge changes to performance with this one, as the home page has fewer images than the products page, which we've already covered in detail. Rendering performance has taken a bit of a hit, but it's small enough not to worry about. Sometimes servers run slow, or sometimes the devices have other tasks running simultaneously, which may marginally impact loading performance. Time to interactive is smaller by 15% though, which, given that rendering performance has gone up slightly, makes this unexpected. My best guess are these web page test metrics. Web page test is recording that the latest report is visually complete half a second faster than before, which could be the reason time to interactive has seen some marginal improvement. Anyhow, that's 6 more points to the Lighthouse score,